Hello and welcome to another full stack tutorial on this channel. This time we're going to talk again about REST and GraphQL with a focus more on REST. Because remember the last video, if you haven't watched it, make sure to watch it. I compared REST against GraphQL and I showed you the benefits of GraphQL. So where you would rather use GraphQL than REST if you wanted to reduce the amount of requests you have to make to a backend or a middleware. Also, if you hear some background noises, sorry for that. There are workers in the apartment above me, so can't do anything about it. It's a little loud sometimes. Anyways, so in the last video, I showed you an example where I have basically this structure here, which is showing typical request I can make via GraphQL. So I can say I want all the users, I want the ID, the name, and the surname of the users. And the users also have friends, some of them at least. And if they have friends, I want the ID, the name, and the surname of those friends. And here you see the response from my GraphQL server. You see most users here don't have any friends, so I just get null. But down here, Michael, he has 3 friends. And instead of just getting a list of friends, those are directly resolved into real user objects again. And that's just a single request. Can also directly request a specific user here. I will change this a bit. The user with the ID 1. So here, Michael. And if I send the request like this, I get all the information I need. So this is the beauty of GraphQL. It makes it very simple. In this example, I also showed how you would do this with REST. Let's head over and I'm gonna quickly repeat this so you see the difference. So let's again use Postman for that. Go into my collection. So here again, similar to what we just did in GraphQL, I want to get information about user 1. So the request looks a little bit different. It's a typical REST endpoint. Basically, with users, I get the complete list of users, and /1, I can provide the ID. And if I send this, what I get is here, the users object with everything in it. So not just like in GraphQL, where we could select what we want in terms of information. I get the complete object. And down here, the friends. This is how it's stored in a database. It's just a comma-separated string of IDs. So if I now want to see who are user 1's friends, I need to make 3 additional requests. Let's just, for example, make one to get the information for friend number 2. So I insert users/2, make the request, and then I'll get the information. Okay, that's John. And then I would do the other 2 requests. So this was the example I showed in the last video. So basically 4 requests you need to do with REST versus a single request with GraphQL if you have such chaining. But even with REST, we can do better. And that's what it comes down to also when deciding what you want to use, REST versus GraphQL. So you don't always need to directly jump to GraphQL. Sometimes you can just design your REST endpoints a little more clever to get nearly the same functionality. So here, for example, instead of having to do 4 requests to get the friends or the objects of the friends of user number 1, we can do just 2 requests. So first again, let's get the information for user 1. So this would be the typical request. Okay, let's just get the information of user 1. And if we wanted to have the information about his friends, what we could say, we design a REST API endpoint, which is called /users/1 and then /friends. And we want that if you use this endpoint, we don't just get here a string, but at this endpoint, we get the list of his friends. So then we just had 2 requests. So by just redesigning our REST API, make it a little bit more flexible, we're already reducing the number of requests we have to do. For this video, we want to focus on that. I want to quickly show you how to use Node.js and Express to create such endpoints. And then I'm also going to show you if, for example, you were to start with REST, how easy the transition to GraphQL would be if you do proper abstraction here. So let's jump into some code. So down here in my repository, which is linked, so you can find it in the description, can explore it. We have the source folder, and I explained this in the last video. We have a data folder which handles database abstraction. So we can have a memory database or using Postgres, which is what I have now. Then we have this GraphQL folder, which contains the implementations for the resolvers and the type defs for GraphQL. We're going to have a brief look at this at the end of this video, just for comparison, but our focus will be here on this. So in the REST folder, I have the current implementation of our endpoints. Before we go in here, I want to show you first how to set up an Express app. So there are thousands of tutorials on this. That's why I won't dwell too much on it. I just quickly gonna go through the essential pieces so you know how to set this up. Also, as I said, just check out my code, can use it as boilerplate. So here in the index is where I set up the Express server. So at the top you see I use a bit more. This is all GraphQL and subscription stuff, but those are the essential imports I need to set up an Express server. So I need cores. If I have a front end which is running on the same server, but maybe on another port. It's usually blocked if I want to access another port on that server on which, for example, my middleware is running. So you need CORS to resolve that, to allow such requests. Then Express, this is the essential piece. This is providing our server. Let's go down. Here I also provide some initial data to the database just for convenience, because I have everything here running in Docker containers. So if you check it out and start up the containers and run the program for the first time, this is the initial data. It's just a demo, so it's nothing like a production application. Then I get some configuration here. I have this in a separate function. From the environment variables, I get all the Postgres stuff. And then down here, we do the actual work of setting up a server. So first here, get the configuration, and then we set up an Express app. We add some middlewares. So as I said, we need CORS and also Express.js. This allows us to receive and send JSON data without the need to stringifying or serializing it. This is then handled directly by this middleware. This line here, typically you don't need it. All the tutorials you'll find online, you'll just have an app.listen at the end. But what this app.listen from Express does, so if you look at their source code, internally it uses basically an HTTP server. And this HTTP server, this is coming from the HTTP module, it's part of Node. And this is actually what's serving your Express app. So all the HTTP connections, communication is actually handled by this HTTP module, and Express is just hooked into it, receives the requests, and then distribute those requests to the different endpoints which you implement using Express. The reason I use this HTTP server is the nature of my demo. I don't just have Express and REST, I also have GraphQL, I have subscriptions, and I need a more modular approach because I also use this HTTP server to set up down here my WebSocket server and all that stuff. But let's just fold this because it's actually not required now for the REST part. Now for better modularity, if you're working with REST, you can split your API into different routes. If you've looked at some bigger REST APIs, usually see they use slash and then they have the name of the main application and then the different endpoints, and then slash another application and the different endpoints. So you can split your big app into different microservices, and it's a good way to use a router for that, because then you can also split those implementations into different files. So here, app use get router, this get router is implemented here. And what I do, I create a router. A router is part of Express, part of the package here. And inside of this router, I then set up the different routes. Those routes, or the logic you see here, it would be the same logic if you would set up those routes directly at the app level, which is what you see in many tutorials. But as I said, I like to put this part into a separate file. And you could think of, okay, I have different routers then. Here, this router is for the users. You could have one for other parts of your application if you have other services. So this way you can nicely separate your code. And you see here we already have some routes. So this is a typical way you implement a get endpoint. Router.get, or if you don't want to use a router, app.get, then we have the string specifying the endpoint. And here this endpoint /users just gives me all the users. And you see those implementations are very small. Typically what you do here, or how I do it, you just do some checking, some error checking, making sure that the input is valid. For example, down here in this other get handler where I expect an ID, I just make sure that the ID is contained, and then I cast it to a number, and then I pass it off to a separate service. So this way you can keep the routing from the actual logic that, for example, retrieves data from a database or from some memory. The router, or this part here, sometimes also called controller, should not be concerned about the details of the actual implementation of getting the data. So let's have, before we continue with what we wanted to do with this friends endpoint, first have a quick look at the service, how it looks. So it's a very simple class here, call it user service. It also gets this iUsers interface, which is defined up here under data. So this is the interface through which I can query the user database. It's an abstraction layer, making it easy to also switch out the database. So if you're interested, just look at my source code here in the data folder. And as you can see, it's very simple. So the get users, for those parts here, it just forwards the request to our database abstraction layer, gets the users. So here it's very simple for those. So you could argue, why do I need it? Why can't I just directly call the users up in the index? And yeah, for those few calls, we already have one abstraction layer. This would be actually fine. But now what we want to do, we want to implement something that's a bit more complex which does not just require one singular request to some database. We now want to implement something which has to request different pieces of data, combine them, and then send them back to the front end, or in our case, Postman. And this will clarify why this additional abstraction here, this additional layer is necessary. Okay, so we're back in the router here, and you see down here we already have a put request for users/id/friends. I showed this in the first video. This is how a user can make friends. So it's a put request, which is typically used to update data. And here you see, okay, we have to check first this parameter here, ID, and then there's also information contained in the body, since it's a put request. And we want to make sure that this friend ID coming from the body is actually a number, because this body is just JSON data. So we want to make sure that it's a number and nothing else, and also that we have this user ID. And then we're handing this request off to our user service, which I just showed, and say we want to make some friends. Then we send the result. Those send result and also this send arrow here have some helper methods here. We're just using typically this response element, which is passed in to this function by this get handler, and we set a status code. So for a result, which works typically 200, which means everything's okay. And then here we attach directly the result as JSON. The error case, we set an error code. So typical error codes I want to use here is 400, which stands for bad request. If the input data doesn't fit what we're expecting, we tell the front end that that was a bad request. But what we wanted to have, and I just showed this already in our Postman, we want to have nearly the same route here. So let's just copy that. But we want not to have it a put, but a get request. So we want to get the friends for a specific user. And how we're going to do it? So first, same as down here, we want to make some checks. So I can maybe copy this, and also down here, this error. We have basically the same error handling, just here I changed the string a bit, so it should be descriptive enough. Down here it says put, up here it says get. Okay, so we have checked the input values. We have error handling. Now what we need to do, we need to make the call to our service. So what we want to do, we want to get a friends array from our users service. And we want to call this get friends. So this function doesn't yet exist. This is the second part. First, let's assume it exists. We need to provide the ID of the user we're interested in, but we need to cast it into a number. And then we send the result, which is the friends array. And to my send method, I also have to pass this response, because as you can see here, send result always uses here the response object to set the status and send the JSON. So we can save this. This part is done. This is just the routing, minimal logic, just some error handling. Now, what we need to do is we implement the service. So the part where we want to do public, where we want to do get friends for a certain ID, we will return a promise, because it's an async method. So it will take some time. We are querying a database. So this is not a synchronous call. We want to return an array of t user data. So t user data is the type which is part of the database schema, contains the user information. So that's what we want to do. And if we don't find anything, if there are no friends, we return null. So far the transpiler here is satisfied, but it wouldn't work. Every time we would call now, we would get back null. So we need to implement now the logic that retrieves the different users for the user with the given ID. So let's just do it a little different. Let's first define this array, set it to null, and at the end we return it. And now here, this is where we implement our logic. So first we need to get access to our user, because what we've seen before, the user actually contains a string, a list of friends. So user with friends equals to await, and here call this users.getUser for the ID. So this here, this call is the same we have up here, the same logic. Now we have access to the user if it exists. So first we need to check if we have a user with friends, and this user has friends, because it's possible we make a request to user where the friends object is just null. We've seen this in our GraphQL response before, which I showed at the beginning of the video. If we actually have a user with friends, what we want to do, okay, we create this friends array, the one we want to return later, and we assign it to this variable. So now what was null before becomes an empty array. And now we need to fill it. And how do we do it? Well, we already have access to the friend IDs. Let me quickly remind you. Let's go to Postman. Let's go again to this get request. Let's get the user 1, send it. So here you see there's a string containing all the friends. So what we will do now in the code, we will turn this into an array and then iterate over it. So let's do const friend IDs equals to user with friends, and we need to split. We split at comma space, which is how the different numbers are separated. And we map this to a number. So this leaves us with an array of numbers over which we can iterate, and I won't use for each here because inside of this loop what we need to do is we need to make asynchronous calls. This is better done with a normal for loop. So we want to loop over the friend IDs, and for each ID we just want to get the user again. It's nearly the same call we have here, where we call this as a friend, and we want the ID of this friend IDs object. So now if we find this user, we need to check this first. If it's not null, then we can push it to our friends array. Now let's save it. And yeah, this is already the complete algorithm. And now you already see that although up here it was just passing through the calls to our database, here it actually makes sense to have this user service because here it involves a little bit more work. And this is work which in the first video I did just in the front end or in Postman by making several calls. But this is your chance if you find you have to do this, if your front end needs to make multiple calls to get data, to think about, okay, could you write an additional endpoint which can combine those calls and make it simpler to get, in this case, for example, an array of specific data. And this brings us already one step closer to what we can do in GraphQL. So let's now quickly test this. Get to our get request, now do /friends, send it, and we get back an invalid request. Okay, so what did we do wrong? Sure enough, there's likely an error, so let's have a quick look. So here, for this get request, I actually don't want to check the body because there is no body. So this is the danger of doing copy and paste, and then you're often left with such little errors because the put request, this needed a body, which we were interested in, but here this get request, we just need the ID. So let's save this, head back to Postman, do the request again, and this time we get an array of all the friends of our user with the ID 1, which was Michael. So as I've shown you, if you design your REST API properly, then you can also reduce the number of requests you need to do certain operations. And the best thing is, if you design it that way, with this abstraction here, with this user service and all those calls here, moving to Apollo or GraphQL later is actually not such a big step. So let's look at the actual implementation in Apollo GraphQL. So you see the structure is very similar. And I also made this throughout my code here. Data, we have the user's model interface. Down here, GraphQL, we have also an index, we have some types, and here also users. This here corresponds to the user service. And this is the essence of GraphQL. What you do, you define the GraphQL types here. And down here, those resolvers, I called it users resolvers. This is very similar to the endpoints, which you define in REST. And let's have a look what we have here. So we have some queries. You can query all the users. You can query a specific user. And here the logic gets a little bit more complicated, and I will not go into the details because in GraphQL, what I showed you, there's some chaining involved because this user object actually contains an array of friends, and GraphQL is able to figure out, okay, those friends need to be also resolved. So this is here, friends are part of user. And here's where I have a logic which is not only similar to what we've just written, it's actually the same. The only difference is here, my access to the database is provided via the context versus down here in my service, it's set up via dependency injection when I create the service. But this iUsers interface is the same like the one we use here. So if you wanted, could extract this code, put it into some separate file to reduce the duplication we have here. But that's not necessary because here I just have both of those because I wanted to show you one versus the other. Typically, you would just have one of the two. So for my case here, for this demo, I just leave this code duplication. But I just wanted to show you how similar the code is and how easy it is to move from REST to GraphQL for certain endpoints if you need it. Now, with what we've just implemented, we're gotten closer to GraphQL, but still what we cannot do, let me go back to the GraphQL here, we will still get the whole objects. With GraphQL, we are very flexible. We can say we're just interested in the name and also in the name of the friends and make a query. And now we get this reduced data. So the filtering is already built into GraphQL and you don't need to overload your connection with unnecessary data. With REST, you always get the complete data set as you define it in your endpoint, and you then have to filter at your front end if you just need specific data. Here with GraphQL, the filtering is already built in, so you have a lot more flexibility. And also what I showed in the last video, you can chain it further, which doesn't make so much sense here for friends of friends. But yeah, if you have more complex data sets, not just only user service, maybe other services connected to other data sources, and those are somehow related, then with GraphQL, you can build very complex calls, get very customized data, versus with REST, you would then really need to make multiple calls, do a lot of filtering. And finally, I also want to point out that this loop here is not needed if you design this abstraction here, this user's data abstraction, a little different, because you don't actually need 3 calls to a database to get those friends. You can do a combined call, and if you want, I leave this optimization up to you. So if you want to check out my code, I can quickly show you how to do it. So I've installed down here the SQL tools, which you can use to get access to the content of the database. So here you see it. We have like 6 users. And what you can also do is you can run SQL calls. And for example, you could, I already have included a few, make a select call for all the users where the ID is just the ID of users you're interested in. For example, 2, 3, and 4, if those are the friends of the user you want. And you can construct this query. You'll also see this in my code. Typically construct those in JavaScript based on input. And that input could be an array, which you then use template literals to fill. So if you make just this call, which is a single call to the database, we just get here the 3 friends. So we don't actually need to make 3 individual calls to the database. I just want to point this out. What I have here, it's just a demo, just for playing around, for showing you how you can work with GraphQL and REST. You can surely optimize it, and yeah, feel free to do so. Okay, so that's it for the video. Hope you liked it. If so, leave a thumbs up, and yeah, see you in the next one. Bye.